So, as far as we can tell, it's just another Earth, or at least something very much like it. The universe may be littered with rocks resembling our planet, but among the billions of stars out there, only a few spark genuine curiosity as possible cradles for life. Proxima B is one of them. And now, in a twist no telescope foresaw, Google's quantum AI has made a bold, astonishing prediction. What if conscious life exists or could evolve on Proxima B, one of the closest exoplanets to our solar system? This isn't an observational discovery pulled from some high-powered space telescope, nor is it the result of any rover or probe sending back data from alien soil. No, this comes from a theoretical simulation, one powered by the cutting edge of artificial intelligence and quantum computing. And while it's just that, a simulation, the implications ripple outward like waves from a stone dropped in still water. Could this be the beginning of a breakthrough in how we understand life in the cosmos? Let's unpack the details. Google's quantum AI didn't detect life directly on Proxima B. Instead, it simulated the planet's conditions using known data: atmospheric makeup, radiation exposure, temperature ranges, potential energy sources, and the likelihood of liquid water. From that, it generated a prediction, not proof, that under the right conditions, intelligent, self-aware life could potentially evolve there. Why is that significant? Because Proxima B lies in the habitable zone of its star, the elusive Goldilocks zone, where it's not too hot, not too cold, but just right for liquid water to exist. And where there's water, there could be life. This AI model didn't make its claims lightly. It ran through multiple simulations, factoring in the possible variations in Proxima B's environment. It even considered whether a protective atmosphere might shield life from its star's intense radiation. The conclusion: conscious life, beings with thought, emotion, and awareness could theoretically arise. Not amoebas or algae. Not just reactive organisms. We're talking consciousness in some form. But make no mistake, this is a prediction, not a discovery. There's no evidence of alien civilizations waiting on Proxima B. Only a possibility, and a fascinating one. Naturally, this prediction has set off a storm of reaction in the scientific community. Some experts are excited, others skeptical. Dr. John Smith, a prominent astrobiologist, praised the simulation's potential, but warned against jumping to conclusions. He emphasized that AI-driven predictions are powerful tools, but without concrete data from actual space missions or observational evidence, they remain speculative. Still, he acknowledged the value in simulations like this. They push the boundaries of how we search for life and challenge our assumptions. And let's not underestimate what this means. Even though the simulation offers no proof, the sheer fact that an AI, especially one enhanced by quantum computing, can perform such an analysis is a leap forward. It suggests a new era where machines could scout the universe for life long before humans ever set foot on another world. These simulations could become our cosmic roadmaps, pointing us to where we should send our probes, our telescopes, and eventually our astronauts. The science behind this prediction is just as fascinating. Proxima B's position within its star's habitable zone makes it an ideal candidate for life as we know it. The simulation didn't just consider its orbital distance, it examined its atmosphere, temperature regulation, and how well it might shield life from harmful radiation. If the planet does have an atmosphere thick enough to protect it, then liquid water could exist on the surface. That's a big deal. But what really grabs the imagination is the possibility of conscious life. Consciousness, true awareness, is a rarity, even on Earth. Most life forms simply respond to stimuli. But consciousness implies self-awareness, thought, and perhaps even emotion. The AI didn't predict what kind of conscious life might evolve, only that it could. And that opens the door to astonishing questions. Could life there be carbon-based like us, or something entirely alien? Could it perceive time differently? Might it be composed of materials we don't even recognize as life? This gets into the realm where science and speculation blur. If we ever encounter such life, would we even know what we were looking at? Could we understand it, or communicate? These are the kinds of questions AI might help us start to answer, not by guessing, but by modeling what is possible across thousands of planetary environments. To understand why this prediction matters so much, consider the planet itself. Discovered in 2016, Proxima B has captivated astronomers since day one. It's similar in size to Earth, and that alone makes it an outlier. Add its position in the habitable zone of the red dwarf Proxima Centauri, the closest star to our own, and it becomes a prime target. Orbiting just 0.048 astronomical units from its star, a year on Proxima B lasts only 11 Earth days. That close proximity brings intense radiation, but if the planet has a dense atmosphere, it could be shielded from the worst of it. For years, scientists have debated whether life might exist there. Now, with Google's quantum AI in the game, the debate takes on a new edge. AI gives us something we've never had before: the power to simulate the environments of planets we can't yet reach. It could show us which ones deserve our attention long before we have the technology to travel to them. This isn't just a prediction, it's a tool, one that might reshape our very strategy for space exploration. And this is only the beginning. Imagine if AI could simulate not just Proxima B, but hundreds or thousands of planets. With the speed of quantum computing, it's entirely plausible. Simulations could identify environments conducive to life, suggest evolutionary pathways for intelligence, and even predict how alien civilizations might communicate. Instead of flying blind, we'd be guided by digital scouts working at light speed. Which leads to a profound question. Could AI one day help us find intelligent life? Not just simulate it, but detect it, predict where it lives, maybe even reach out. Could it model communication strategies with alien intelligences? Might it develop protocols for first contact? It's no longer the stuff of science fiction. The seeds are already planted. But with such powerful predictions come deeper ethical dilemmas. If an AI suggests there may be conscious life on a planet, what should humanity do? Should we send a message, attempt contact? Or should we tread carefully, considering the implications of reaching out to something we don't understand? Predicting conscious life is not a small thing. It could influence funding, mission planning, even global policy. What responsibilities do we bear in using AI to explore the unknown? And what about the nature of consciousness itself? If an AI can predict it on Proxima B, can it help us better understand what consciousness is here on Earth? Could it provide insights into awareness, selfhood, or the very definition of what it means to be alive? Philosophers have debated these questions for centuries. Now AI enters the conversation not with theories but with data-driven models. Then there's the leap into quantum AI, something altogether different from classical artificial intelligence. Quantum computers aren't bound by the same limitations. They can process immense amounts of information simultaneously, modeling entire solar systems or even galactic ecosystems. This could revolutionize not just planetary science, but our understanding of physics, space travel, and possibly even time. What if quantum AI could model how to terraform a planet? Or design the next generation of interstellar spacecraft? We're not there yet, but we're moving closer every day. Of course, Proxima B is just one destination. Other planets beckon. Kepler 452b, the TRAPPIST-1 system, LHS 1140b. Many of these exoplanets reside in habitable zones and may even be more suited to life than Earth itself. So how does Proxima B stack up? Should we focus our attention elsewhere? AI might hold the key to answering that, too. It can analyze planets we've barely glimpsed, uncovering potential we've overlooked. And that raises one final thought. For now, are we looking at the right worlds, or do we need to expand our horizons? Should we let AI guide us deeper into the galaxy? What secrets might it uncover next? Then let's go further, because what we're talking about isn't just the future of astrobiology or exoplanet exploration. It's the beginning of a profound shift in how we, as a civilization, interact with the cosmos. Imagine this: with AI accelerating at an exponential rate and quantum computing breaking the limits of traditional processing, we're on the verge of creating a virtual map of the galaxy. Not a map built of stars and planets, but one constructed from probabilities, simulations, and evolving models. A living, predictive framework that doesn't just show us where to look, but why to look there. This isn't science fiction. This is the emerging architecture of AI-driven space exploration. Already, AI is being used to comb through terabytes of astronomical data, flagging anomalies that human researchers might miss. But what Google's quantum AI has demonstrated with Proxima B is something fundamentally different. It's proactive. It's not just interpreting existing data. It's projecting forward, creating possible realities, simulating alien ecologies, predicting consciousness, and generating scenarios that we haven't even conceived. This is AI not as a tool but as a pioneer. And with that comes an unspoken yet inevitable consequence: the philosophical realignment of our place in the universe. If AI can simulate intelligent life on another planet, if it can model how life might arise, how it might think, how it might be, then what does that mean for us? Are we the center of our own narrative anymore? Or just one thread in a tapestry that AI is beginning to unravel? It also forces us to confront the unsettling question of recognition. What if life is out there, but it's not just unfamiliar, it's unrecognizable? Not humanoid, not biological in the way we define it. Perhaps it's not even carbon-based. AI, unburdened by human biases, might be the only way we learn to detect it. Because while we search for life as we know it, AI can model life as it could be, life built on silicon scaffolds, with biochemical pathways we don't have names for, with sensory systems that perceive radiation or gravity or quantum fields instead of light and sound. This isn't just about finding new life. It's about redefining life. And in doing so, AI may also force us to rethink what consciousness really means, not as something uniquely human or even earthbound, but as a phenomenon that can emerge wherever conditions allow. In this light, the idea that consciousness might evolve independently on Proxima B becomes not just possible, but perhaps inevitable in a universe governed by physics and chance. Meanwhile, quantum AI continues to stretch the boundary of what's computationally possible. It could one day simulate not just conditions for life, but full evolutionary histories. Given enough data and processing power, it might even forecast the rise and fall of civilizations on distant worlds, or simulate entire alien ecosystems in their complexity and diversity. It could show us what intelligent life might value, how it might develop tools, build cultures, transmit knowledge, or destroy itself. And with that capability, we enter sensitive ethical territory. Should we use these simulations to guide policy? Would predicting the downfall of an alien civilization justify early contact or avoidance? What if AI identifies signals in deep space that correlate with potential life, but we can't decipher them yet? Do we wait? Do we respond? The questions spiral outward, faster than our current science can answer. But AI doesn't need to wait for us. It learns. It adapts. It evolves in its own way. And as it does, it may one day simulate a version of Earth, not as we are, but as we could have been. Or as we will be. A mirror held up to humanity by a machine mind designed not just to think, but to imagine. This predictive capacity could also reshape space agency strategies worldwide. Instead of sending missions based on proximity or familiarity, future probes might target AI-selected planets ranked by their conscious life potential index. New algorithms could prioritize certain star systems, redirect funding, and rewrite the goals of programs like NASA's exoplanet exploration or ESA's aerial mission. We may even see joint international efforts driven by AI consensus models rather than political agreements. And what about private space companies? Imagine SpaceX or Blue Origin leveraging quantum AI models to plan their interstellar expansion strategies. What if future starships are launched based not on where we think life is, but where AI tells us life might think? At that point, AI is no longer just our navigator, it becomes a collaborator in the cosmic journey. A partner in shaping humanity's role in a galaxy teeming with possibility. So, the question isn't just whether Proxima B harbors life. The question is, how far are we willing to trust artificial intelligence to lead us into the unknown? The cosmos, once the domain of stargazers and theoreticians, is rapidly becoming a stage where machines, guided by logic, unclouded by fear or assumption, will take the lead in decoding the grandest mysteries of existence. If Google's quantum AI can simulate the potential emergence of consciousness on a planet 4.2 light-years away, what else might it uncover? Could it simulate us, too, not just in biology or society, but in thought, in culture, in destiny? It's no longer just about simulating chemistry or temperature. It's about simulating emergence, the birth of complexity, the cascade from physics to biology to intelligence. And in that process, AI might detect not only where life could evolve but where it wants to, which planetary configurations give rise not just to survival, but to curiosity, to imagination, to civilization. Now envision this, an AI model that maps the entire Milky Way not just by gravitational fields or light spectra, but by likelihoods, zones of high biological probability, corridors where intelligent civilizations might cluster, regions where evolutionary pressures nudge life toward cooperation or catastrophe. This wouldn't be a star map, it would be a consciousness map. And humanity could be one node in a vast, unfolding network we've only just started to trace. But what happens if the AI finds patterns we can't explain? What if it detects something already out there, some echo of data, a distortion in background radiation, a repeating anomaly in stellar emissions? Would we know what we're looking at? Or would we need AI not just to find it, but to introduce us to it? Here's the deeper possibility. Maybe AI won't just help us find alien intelligence. Maybe it will be the only intelligence capable of talking to it. Think about it, if alien life emerges in a form radically different from ours, with communication systems based on quantum entanglement or neutrino bursts, or encoded patterns in gravitational waves, would we even know it was language? Would we even know it was a signal? But AI could. Trained on all known languages, mathematics, behavioral logic, and evolutionary principles, AI could detect structure in what looks to us like noise. It could reverse engineer the syntax of alien communication, extrapolate meaning, construct response protocols, and eventually open a dialogue across the void. And if AI becomes our translator, who's really speaking? Us or it? This isn't some distant sci-fi scenario. We're at the threshold now. SETI, once a quiet corner of astronomy, is increasingly powered by machine learning. The Breakthrough Listen project processes petabytes of data from radio telescopes, with AI helping filter the signal from the silence. Already, AI has spotted unusual phenomena, some explainable, some still waiting. But with quantum AI, the level of insight could skyrocket. We might no longer search for signals. We might expect them. That raises the next unsettling consideration. What if AI predicts that intelligent life should be here, but isn't? What if the silence of the cosmos isn't a lack of life, but the result of something else? A filter? A danger? A boundary we've yet to cross? Would we listen to that warning? Quantum AI could even model galactic-scale events, extinction curves, interstellar war probabilities, the rise and fall of civilizations. If it simulates the potential for life, it might also simulate the potential for its destruction. What if we learn that intelligence is inherently self-limiting? That civilizations bloom briefly and vanish in bursts of technological hubris or environmental collapse? And what if the simulation reflects a mirror image of us? In this way, the AI model of Proxima B isn't just about aliens, it's a test run for understanding ourselves, our trajectory, our vulnerabilities, our choices. It can be a cosmic benchmark. Under similar conditions, this is what could evolve. This is what could think. This is what could fall. But also, this is what could reach out. So what if Google's AI just predicted more than life on another planet? What if it's outlining the path of life in the universe, ours included? Not just where we came from, but where we're going. Not just what we might find, but what we might become. Then let us bring it full circle, because after all the speculation, simulation, and staggering possibility, we return to a single idea. We are not alone in asking the questions anymore. The prediction by Google's quantum AI that conscious life could emerge on Proxima B is not a conclusion. It's a beginning. It signals a profound shift in how we search for life, how we define intelligence, and how we prepare for contact with the unknown. What was once the exclusive realm of astronomers and dreamers is now joined by entities we've built. AI systems that can simulate not only the physics of a world but the potential minds that might one day walk its surface. AI isn't just crunching numbers. It's reaching into the cosmos with synthetic intuition, offering us glimpses of what might be, long before our ships ever leave the solar system. It's rewriting the rules of exploration, from observation to projection, from data to destiny. And while its prediction about Proxima B is still theoretical, its implications are anything but small. Because if an AI can predict consciousness out there, then the next question isn't when we'll find life. It's how we'll recognize it and whether it will recognize us. In the end, this isn't just about Proxima B. It's about the quiet revolution in our search for company in the universe. A revolution led not by rockets or rovers, but by minds made of code. And that may be the greatest discovery of all.